right, so we got a request for 120 and 121. If you are done with 433 and are just sitting here kind of with like quote unquote nothing to do, you can come on up and grab the closure. Ooh, you already grabbed it like at math lunch, whatever, you don't need it. But I need people just chilling and like not being distracting right now while we go over this stuff. Hey, look, the corner of my expression mat. $120. 120 is what we would call a subdivision problem. Not like the places where you have houses, but people in music are often subdividing pieces of music. So we have an entire section that is 36, and it is divided into 3 jumps, right? 3 gaps, 3 whatever you want to call it. So we're going to take the entire distance and divide by the number of jumps. That gets us 12 per jump. So we'd have 12 there, then 24 there, then 36 there. And then I had a couple people come ask about what is this asking for. It's saying how far is it from here to here? Which when we start at 0, that feels kind of not difficult sometimes. When we don't start at 0 is when it's more difficult, right? So this answer right here would be that this section is 24 long for A, because it's 2 of our 12 sections. For B, it's 36 still, a length of 36, but it's divided by 1, 2, 3, 4 sections. So we would do 36 divided by 4, not quite sure where to write it. That comes out to be 9. Yeah, I think that's 9, so we'd have 9 here, 18, 27, and the math should work out to get us to 36. And then how long would 2 sections of 9 be? 18. Questions on that? So then C changes things up. We got 16. We count our jumps. Guys, careful. I worked with a couple people who said count your tick marks. I know some teachers tell you that, but that's dangerous because there's a tick mark at the start and a tick mark at the end. You actually end up with 1 extra tick mark compared to jumps. So it's like if you count the starting line and the finish line, right? So we have 1, 2, 3, 4, 5, 6, 7, 8 jumps here. So we're going to do 16 divided by 8, which is what? 2, making each gap 2. I will leave this one for you to finish and figure out how long this region is. And then 121. This is like just getting into the next chapter worth of like us looking at data and looking at like sets of numbers and like what doesn't match. Who plays a sport? Any sport, golf, frisbee, any sport at all, okay? So if you're on a team, normally you look around at your team and kind of compare yourself to them. I, unfortunate because I was not very well coordinated, got tall early. Like I hit my growth spurts early, and I think one of these students had the same thing happen to them. Everyone's right about 70, right? 70, 77, 75, 68, 70, 72. And then there's this person who is a good, like 13 inches taller than anybody else on the team. So guys, the next tallest person is 75. This person's a foot taller than everybody else. So we could divide that by 12 and figure that out, right? So if you did 88 divided by 12. But we don't even need to figure out how tall they are. It's just that number doesn't really seem to fit. So that's what I'm asking is which number does not seem to fit this set of data? And then this is when referees will be like, hey, How old is that kid? Is he allowed to be on your team? Like, is he like a secret next grade up and you're like trying to cheat? But sometimes kids just hit their growth spurts early. But who's ever played on teams that like you're only allowed to be a certain age? Yeah, and then you have to go to the next level up. Yeah, this is where people start to pay attention. Like, oh, you're extra tall. And then because Chris had said the Rockets does not seem to have any really tall players, well, I guess now then we should probably figure out, well, how tall is the 88 inches? So 88 divided by 12. Holy cow. This person's over 7 feet tall. Guys, I'm 6'2". 7 feet tall, they'd hit their head at that door. That door is probably a 7 foot tall door, than most doors are, that they would hit their head. So no, I do not agree with Chris. We've got a 7 foot tall person. That shouldn't go there. 7 foot tall. And actually more than 7 feet, right? 7.3. So that'd be another third of a foot. How many inches is a third of a foot? 4, right? So they're actually 7 feet 4 inches tall. That's insane. I think that's taller than my friend's brother Daniel, who was always, every time he came to our house, he would hit his head. And of course, because we were little siblings, we'd laugh at him. But now I realize that was probably not fun. Yeah, Lucas?
My grandma's house, there's a wall of all the heights. And one of my uncle's friends, they came over to watch their dog, and his tick mark is at the very top of the floor.
That's awesome. So he has to duck.
There's not even an inch of space up there.
Yeah.
He's just all the way to the top.
If you do your hair up, you're brushing into stuff. The first car I owned was like a little Honda Civic. And in high school, we would spike our hair because we thought it looked good. It did not look good. And I would get in my car and my hair would hit the top of the car. So I would just open the sunroof. Also, when I was on swim team, if you can imagine this is not made up. This is true. We would grow our hair out all season, and then we would do it like crazy. And one year I had a mohawk that split to 2 different mohawks. It was pretty sweet. One year I just did Liberty spikes because I wasn't allowed to cut my hair that year. So we did red sparkly Liberty spikes.
Wait, do you have pictures of that?
I'll have to look for them.
I want to see pictures of that. That would be funny.
Yeah, like Scouts Honor, I did that stuff. Swim team, high school swim teams, you do some weird things. Other questions from the homework? And anyone who's super confused right now, we did that because then we would shave our head to go faster through the water. 117. Guys, in your homework, if you grabbed it early, ooh, thank you so much. I was waiting for somebody to ask about that one, Eve. Guys, I bet 5 of you are thankful that Eve just asked that question. So this is what we were working on yesterday, and it was brand new, so it probably wasn't super easy to practice. If we circle the x and the negative x, we make what we called yesterday a zero pair. Shaded's positive. We coded that. Actually, we forgot to code that on our expression mat, so we're going to do that today. I realized in the afternoon. So then, a -1 and a +1 can also zero pair out. This +1 and -1 can zero pair out. And we're left with -1x and -1 because they're the not shaded, making them the negative. Over in B, what could I cancel out here? Yeah, the empty x plus the positive x, so the negative x and positive x, and the 1 and the 1 and -1, right? So then we get left with x squared and x. Alrighty then. If you want any more help, math lunch is still a thing that's happening. I am trying to get people mastered before next week. I know tomorrow is our mastery deadline. So if I invite you to math lunch, you probably maybe want to come so that we can get you mastered. So you can go to Discovery Day. All right, so now if 433 is ready to turn that in. You can grab a closure up front if you would like, or I will pass them out later. And then get out your expression mat, your algebra tiles, and your graph paper. Actually, let's just go ahead and put closure in your possession right now. So either get out the closure, or I'm going to come bring you a copy of closure. Okay, so you got it, you got it, you got it. Got it. There we go. You got it. Got closure yet? Yep. Closure. Yeah, you have one. You weren't even here yesterday, were you? And you somehow already got close. You need 4, 3, or no, you probably already had that too. You're just on top of it, Farm. You're just rocking. Y'all got it? Y'all got, man, you guys are just on your A game. So, one of the hardest parts about math, and I blame Mrs. Goldring's class for this, I blame language arts, is turning a verbal sentence into what it means mathematically. So give me your eyes up here real quick. If I said the sentence, we have 3 sets of a number plus 1. Or, sorry, a number plus 2. I was debating this morning what to do. So, a number is like our x, right? The thing that we don't know. And then, the things we do know are our 1s. So, 3 sets of a number plus 2 would look like this. I got some eyes not up here, and I'm worried that you're not going to know what to do. If you're working on the closure, I'm going to come around and take it away, so you better put it under your binder, or under your expression mat, somewhere that is not tempting. Guys, it's really easy to tell when you're writing and I'm not asking you to write. That means you're doing something different. So then, if I were asked to write this out, 3 sets of a number plus 2, I could write out as 3 of tells me to multiply, so we use our parentheses, and our groups that I made are x plus 2. I got 3 of them. If I'm then asked to simplify that and say, what do I have in total? I do the multiplication, and I got 3x and 6. Does this make sense? Really what I'm saying is, do we have any questions? Also, take a moment. Above, we put this on your paper yesterday, but above the shaded tile, write a +1. And above the empty tile, write a -1 so that you can remember what's positive and what's negative. Shaded is positive. Empty is negative. So now, you're going to do the same thing that I just did. One of your expressions with parentheses. One of them not, for these 4 sentences. I will be making laps. Ms. Martin will probably be making laps. Let us know if you have questions. But for each of these, for each of these, you should have something written involving parentheses, and it says this up here. And then you should also have something written not involving parentheses, like what I just showed you. Okay? Questions? Have at it. I'm probably going to try to give you at least 5 minutes. So you need a piece of graph paper to write on, and then also your expression mat. Also your expression mat. If A is too difficult, skip it, move on to B. B is too difficult, skip it, move on to C. Like, find one that you like. You guys don't have to get all of them out. I love what you're doing. It's very OCD, but you don't have to. I might suggest that you skip A. If you understand what A is asking, go ahead and try it. But you might want to skip it. It's a little difficult. Try to get off two equal groups of 3x's and -2. Those are x squared. Careful, x versus x squared. Kylie, I think you ended up with a double bag. You can try some of these out. Pull out some of the big ones. Ooh, where's your one with parentheses? Oh, we gotta write one with parentheses. Sure. Actually, that's a fantastic idea. Hey, that piece of paper in your bags, I'll come around and collect those if you don't want it. I know it kind of gets in the way. You don't need this. So if this is still in your bag, it kind of gets in the way. Yeah, now you're in the All right, to check if we're on the right track, you're not out of time. But if I were to try to do B, two equal groups of 3x minus 2, two groups, one group, two group of 3x's minus 2. Right? They said two groups, 3x, I got my 3x, minus 2, I would need to be negative. So when we go to write that out on our graph paper, I'm just going to go ahead and put B first. Oh, let's use some cards. Carmen, can you tell me what to write when I have two groups of something? You're good. Just, can you tell me what to write when we have two of something? What does of tell us to do? Carmen, you threw your voice all the way across the room. That was very impressive. You should probably become a ventriloquist. 2 times, right? You can put the dot if you want to, or not, but B told us 2 equal groups. What was in each group? 3x's and negative 2. When we first started talking about distributing, I brought up putting the arrows on the bottom. What's 2 times 3x? 2 times 3x, how many x's do I have in total? 6x minus, well, what? So I have negative 2 here, negative 2 there. What do I actually have? Negative 4. So I could also write 6x plus negative 4. Any questions on why that is what I would write for B? Because I want you to try to do C and D on your own, We'll do A together if you guys want, but try to do C and D on your own. Remember, the X's are our rectangles right here. So if we have 4 rows of 4 rows of 4 rows of because I don't just like have it like ready to grab because it's weird paper. Let me see if I have extra. You talking about like the isometric paper or whatever I called it? Rows of would tell us to multiply. So if we start trying to build this, 4 rows, so 2x and a 1. Guys, I'm going to actually make rows, right? I'm going to actually make rows. So another 2x and 1. Another 2x and 1. Who, what? Wait, you said something.
Well, yeah, but it's always something that the person who said it doesn't.
4 rows of. Same thing in each row. 2x plus 1. So when we go to write this out, Antonella, can you tell me how you would write this? What does 4 of tell us to start with? Gotta get my paper straight. What does of tell us to do? You can tag team a friend if you need. Ooh, multiplication, right? So 4 rows of says multiply. Whatever you got in each row, guys, if you need to on your paper, you can also do this. Like 4 times whatever's in each row. So what we're going to have is 4 times, what did we say each row had? Well, we can look. What does each row have? Yeah, 2x plus 1. And when we do the multiplication, what's 4 times 2x? 8x. What's 4 times 1? So when we rewrite it, now we could have written it out here, right? You can work these horizontally if you want. I just like to work down. Questions on that being 4 rows of 2x plus 1. 4 rows, 2x plus 1. My camera froze now. All right, this is a tough one, so you can pass if you want. But Aiden, how can I set up, using algebra tiles, a number increased by 1, then tripled? So 1x plus 1. So a number increased by 1. X and 1. Guys, take a pause. Does this make sense why Aiden said this is a number increased by 1? 1x, 1, 1. Then, what'd you tell me to do, Aiden? And yeah, then make 3 of them, because then we triple it. So this is for D, guys. This is for D. Aiden said do an x plus a 1, and then do 3 of them. When we go to write this, Aiden, do you want to keep telling me how to write it, or move on to the next card? Ooh, yeah, we want to write the total, too, so we want to do the multiplication. Yeah, so then in total, we have 3 x's and 3. So those tiles, we have 3x and 3. Questions? A's fairly tricky. Anyone think they know how to do A? I won't make you do it under the camera. You can come up and try it first, and then we'll turn the camera back on if you want. Talk about A with your team. You want to come try it, John? You're the only one to put your hand up, so you're living risky. Risky business. So they're going to work while you come up and try it out, and once we get it right, then we can show it. All right, so camera's off, but you can go ahead and set up what you want. The area of a rectangle with a width of 3. Yeah, you can move those. And a length of x plus 5.
Thanks.
Camera's off, so you can just do it.
Oh.
I mean, I can turn it on and you can look at the other screen. I just don't want people watching you while you're trying to build it. So, move this over here.
So,
with the 3, length of x plus 5.
I need 5 of these little.
Or you could use 5 tiles.
Or I could.
I'm going to drink some coffee since you're going to teach my class for me. Yes. Sure. If you get it done, then we're all good. No, it's by the end of the day. Right, by the end of the day. I don't have time during the day to count and do math and figure this stuff out. I have to do that at night.
And then, well, since its length is like, and then what?
So, here's a hint. You now have made this 4. So, if we do this, that's a width of 3. Because each of these butts, each of these ends, whatever you want to call it, those are each 1, right? So this is a width of 3. Right now our length is x. So if you want your length to be x plus 5, do you think you can explain that to the class? So I want you to build it like while they watch you, and I want you to bring in the tiles and explain this is a width of 3 on this side, right? And then right now it's a length of x. If we want to increase the length, we bring it in. Make sense? You ready to be me? I might have to pay you after class then. I'm gonna squeeze down.
Okay.
You should do the claps, it'll be funny. Mr. Abbott is in charge now. He's your guest teacher. Everyone say hi, Mr. Abbott.
Okay. So. Okay.
Listen.
So since it's the area of a rectangle, we're doing it's the width and the length. If you take these 3 okay, okay, so if you take these 3 x's, right here is a length of like right here is a length of 3 units. This is the
But those are X tiles.
Yes, but the end of the X tile is 1 unit. Is 1 unit.
Ah.
And then so it's 3. And then since the length is X plus 5, you already have the X right here. So if you take this, it's basically just adding 5. Again.
But wait, you only put 1 tile. How one?
This is the a 5 tile. It's,
what if I don't have any of those?
then you do this. Well, you should, but then you take 5 of these little mans. Little
man.
blocks. Yes, there.
And is that everything, or do I need more?
That's it.
That's it. That's all the tiles I need to use.
Yeah. Oh wait.
Those other rows don't look finished.
Oh yes. Okay. So what you're basically gonna do. Oh wait, that's 4. You do that.
There we go.
This, and then if you're
That
gonna
looks like a
fill in
rocket
the
ship.
rectangle, you're gonna put in 1.
Ah, very good work, Mr. Rabbit. All right, so guys, this is really confusing. This, and like John and I talked this out, if you ever want to teach, all you have to do is ask me. I'm not going to put you on the spot. We can talk first, and then you can teach the class. So, like, John has to come up and do this, and he had a slight misstep at first. Totally fine. That's learning. So these ends are 1s, right? So together, these are 3. I don't have to use 1 tiles to make a width of 1 because these have a width of 1. If it helps you, and you probably don't have a Sharpie handy, but like I labeled my 1 tile X, and you could put a 1 right here. That it's hard to tell that that's a 1, right? So I mean, I could put like 1 over here. And this is why I have those cardboard X tiles up on the board, right? So this is now 3. This is a length of X, and now it's X plus 5. So when we go to write it out, guys, you need it written out. When you go to write it out, we have, 3 by, Sharpie on my desk, X plus 5. Right? Width of 3, length of X plus 5. So we're discussing area here. Right? This is area. What's 3 times X? 3X. What's 3 times 5? 15. And in total, we have 3 X's and 15 of the 1 tiles. Questions? If you want to bag up your algebra tiles, you might want them for the next problems, but I kind of doubt it. Like, I don't think you're going to need them, actually. Then on your notes graph paper, so not your expression map, but on your notes graph paper, go ahead and put 108. I need a new sheet of paper. 108. 108. Whatever you're taking notes on. Yeah, so if you want, you can bump over like this part here. I like to use the whole page and kind of draw a line to split things up. We are going to go 1 by 1 here and just make it through what we can. We might not get through all of these, but that is fine. Everybody, copy down. -1. So we're doing A. -1. You guys wait. Yeah, anybody else wait with your algebra tiles. We got to do this problem. We can put those away in a minute. -1 plus -4x. Ooh, all of those would have been red if I was laying out the tiles. Plus 2 plus 2x plus x. Now I know this is a tad bit more stressful, but we're going to do this live. I'm not going to give you a head start because we're at the end of class. So each person that I call on, I just want you to tell me one thing I can do. Something I can put together, something I can like take apart, something I can make 0 with, or you can pass. So, Jesus, give me one thing I can do. Can I put something together up here? What can I put together? And? You're right. It can go with something. So I look at this too. Those were like 1 tiles, right? The little mans. Do I have any other 1 tiles? -1. Speak up, Jesus. So a +2 and a -1. What do those combine to make? +1. Now I also could have moved these around if you would like it better that way. But +2, -1 makes +1. Deekshita, tell me something I can put together. -4x plus 2x. Can you guys now potentially see why we use the commutative property sometimes to move stuff around? It's nicer when it's next to each other, but what's that make, Deekshita? -2x. And we still haven't talked about or done anything with the plus x out here.
Wait, you add the x and then...
Farah, what could I do now? Could I add the 1 and the -2x?
Yeah, but you could also do... Well, no, but you could do -2x plus x.
Yeah. Farah, I love that you caught yourself. You were like, yeah, but well, actually, no. Like, so guys, Farah clarified, we can't add these. They're not like, right? That's a 1 tile, little man. And these are x tiles. So, -2x plus x, -1x. 1 plus a -1x. Does that make sense? You're going to do B with a head start. All right, so B, you get a head start. No, let's jump to C. That's actually going to be easier because that's probably all that we have time for. Expect B and D to be on review Jenga tomorrow. Expect these to be on Jenga. Hint, hint. I don't even know if I can call it a hint at that point. Absolutely. Yeah, I know that doesn't really keep anything secret. You can expect closure problems and problems from through the entire chapter worth of homework. Okay, so this time I'm trying to make 30 problems in there, so there's plenty of problems for us to choose and get to. Because we also might play Jenga on Monday. Ooh, we're running out of time fast. So Marina, can you tell me something that we can combine together up here? Yeah, because they're the same size. They're the same tile type, right? X squared, X squared. We can put these together. And what do we get then? Yeah, +1 x squared. Thank you. I was holding my breath. I was getting nervous. You make me hold my breath too long. It might not go well. Isabella, what else can I combine? Yeah, because they're both the little rectangle tiles. Say that 5 times fast. What do we get then? A +1x. Layla, can I put together x squared and x? No, because they're not like tiles. They're not like terms. You cannot add these. Because one is a square, one is a rectangle. Now, that's all the time I got. Have a wonderful day. Thank you very much. Turn in your homework if you didn't. Come to math lunch if your homework isn't done. Really quickly, I'm going to pause my video, but really quickly,